Hello everyone, my name is Stannard. I'm the founder and CEO of a company called Petabridge, and normally when I give conference talks, it's usually about stuff we did competently or things that were successful, generally speaking. This talk is about my greatest professional embarrassment and what you all can learn from it. So I hope you enjoy the rewrite from hell. So a little backstory about us. So we were founded in 2015, and we are the commercial entity, Petabridge, my company, behind Akka.net, popular distributed actor framework in .NET. We deal with lots of pretty complex technical challenges like distributed systems and concurrency and real-time software. Pretty highly technically capable stuff. And most of the way we've monetized that project, which is all, Akka.net's all Apache 2.0, so it's free. We primarily sell human-powered services, consulting, training, and support. And in order to grow that business, we have to have really high standards for ourselves and our prospective candidates we might want to hire. And these are the explicit values I have listed in our onboarding documents. Service the customer above all else, unequivocal excellence, hungry for achievement, fanatic attention to detail, and encourage individual initiative. This is a story of how we completely failed to live up to any of those values. The SDK bin story is the product we're going to be talking about today. It consists of 5 parts: the development, the disaster when we launched it, the years of despair where it languished and basically killed a whole bunch of opportunities for us, finally getting the courage to go and do something about it and fix it, and the delivery, the successful turnaround of the project, so far anyway. Our story with SDK bin actually begins a couple years earlier, in 2018. After 3 years of trying to run a commercial open source business, which is pretty challenging, we decided that we needed a product. We needed the ability to basically take our expertise and amortize it into a piece of software and sell that, because that was much more scalable than consulting, support, and training. So we decided to make Phobos, a paid telemetry product for Akka.net. It was essentially a NuGet package that was proprietary. We came out with per node pricing, meaning the more you use, the more it costs. Customers hated that. And then we also fulfilled the service by using a MyGet subscription. MyGet was a private NuGet package hosting service, but it had a key feature that was really useful, which is you could have a private, sort of feed, like a canonical NuGet feed where you published your product, and you could give your customers a read-only mirror to that feed. So that gave us kind of a low-cost way of building a distribution system for this product. Customers hated that too because it was confusing. They relied on us to give them their credentials, and people would forget about it and not use it. And as a result, Phobos was basically a commercial failure for its first 2 years. We only had 3 paying customers at the time we launched SDK bin, and it was largely because of these 2 friction points. So we knew that Phobos met a market need. We knew that based off our customer conversations. And pricing is a relatively easy problem to solve, but the distribution and fulfillment problem was more challenging. We basically knew we had to invent something new in order to deliver that. And thus the idea for SDK bin was born. But I'm pretty ambitious, I'm an entrepreneur, so I had decided to take it a step further than just solving our own problem. What if we solved everyone else's problems? Every other company that sold proprietary NuGet packages probably has this exact same issue. So let's try to build a platform and we could open up a whole new line of business around that. And that was the basic idea. So we get into the development of SDK bin. At the beginning of 2020, I pitched it to our team. I had prepared over the holidays all of these slide decks, all of these balsamic mock-ups that were clickable. Basically a pretty full-throated vision for what it was we were going to deliver. We had a small team. We've always had a small team. There was me. I'm wearing a lot of hats. And basically most of what I spent my time doing was actually generating business. I was the one doing sales, marketing, and fulfilling most of the training, all the training and consulting. We had a dedicated engineer I hired specifically to build SDK bin. He was a former startup CTO based out of Moscow. And he was going to own the end-to-end implementation. He was a self-professed full-stack developer, and he was very well compensated and expensive, so we definitely didn't cheap out there. And we had another Akadana engineer I opportunistically hired at the beginning of 2020 who had been a contributor to the Akadana open source project. His gaming studio went bankrupt and he needed a job. And I brought him aboard to help me with the major Akadana release we were doing right around the same time. Our target date was to get a minimum viable product to market by August of 2020, so about 7 months. Pretty achievable considering we would have a dedicated resource working full time on it with nothing but it, with no bureaucracy. It was a complete greenfield project, so it's not like there was a lot of big pieces we had to work around there. And on top of that, we had a pretty good scope on keeping this minimum viable product minimal. It was going to be us only as the only publisher, Phobos as the only product, Stripe as the only billing system. So from a responsibility standpoint, our Akadana engineer was helping me with the Akadana release and support. He was not active on this project until much later. I was responsible for doing the specifications, the requirements, doing the graphic design, some of the key data flows and security constraints, and then building out our cloud infrastructure was my job. The SDK bin lead was basically supposed to deliver the entire application end to end. So this is the database, the application, the front end, and the back end. And the front end in this case is going to be our Chekhov's gun. It's going to come back a little bit later and fire. So something happened around February 2020. Don't know if you guys remember a little thing called COVID. So COVID showed up and immediately nuked 40 to 50% of our sales. Because we sold on-site training and consulting. That was our most popular product or service category in 2019. So all of that revenue was annihilated. On top of that, 30 to 40% of our customers were in industries that were especially impacted by COVID. Sports betting, travel, etc. One of our biggest subscription customers at the time was Jet2, the discount airline. And I remember watching a flight aware chart of all their planes being turned around from Spain when Spain closed its border. And I was waiting for a wire transfer from them to come in. And I thought, dude, if this doesn't happen, I think we're screwed. Thankfully, it did come through. But the point of all this is that, oh yeah, one more little detail. My wedding got force majeured by COVID too, as my wife in the oil industry likes to say. So long story short, I had some distractions while SDK bin was being built out. My primary responsibility came to basically making sure the company didn't die and that everyone's paychecks cleared. So SDK bin became a much lower priority for me right about 2 weeks into its implementation. But things looked like they were going pretty good at first. We had the initial foundations laid by February. By March, we had a functioning sort of NuGet service endpoint that was able to deal with proxies and canonical feeds, even things like trials of packages. That was all done. And then in April 2020, we had successfully finished all of the edge cases working with real NuGet clients. This is all looking pretty good so far. I didn't see a need to look real closely. And this is where I made my first strategic mistake. Actually, no, I made a mistake even earlier than this, but we'll get to that later. My first big mistake was not looking under the covers at the decisions that were being made while I was asleep. So I've got a developer in Moscow, I'm in Houston. By the time I logged in, a full day of architecture decisions were already made. And I had a lot of stress on my plate, a lot going on, but it would not have taken me that long to go and look. I didn't look because my management philosophy, which had worked for me at my previous company, was basically directionally correct, which is hire talented people, give them the resources, direction, and support they need to do their jobs, and then back off. Stay out of their way and let them do it. That is, like I said, directionally correct, but there's a key facet of it, which is you've got to verify alignment really, really early, and the longer you put it off, the more expensive it's going to become. That's exactly what happened here. Because let me show you what happened in the 6th ever commit made to SDK bin. This bad boy got introduced. Now, if you're a .NET developer, you have probably seen this monstrosity before. This is known as the generic repository pattern. And if you want to cast a years-long curse on an employer you hate, this is a perfect way to do it. The reason why this is such a piece of cancerous code is it does a couple of things. First, it treats every entity in your database. This is using Entity Framework Core and AutoMapper because, of course, it does. This treats every entity as essentially having the same persistence requirements, regardless of what it actually does. NuGet in particular, which is the first product type we're fulfilling, a NuGet write operation is really simple. You're dealing with one version of one package, and it's an immutable operation after you publish it to a feed. Pretty easy to deal with. A NuGet feed, the read side, which is what all the customers care about, is like an aggregate of aggregates, several layers down. This design resulted in lots of Cartesian explosions happening everywhere inside our database, to a point where the total bandwidth we were pulling out of Azure, SQL Azure, was about 4 times the size of the total on-disk footprint of the database. So that was one set of issues here, was that we had this sort of pretty bad data access layer design from the beginning. But there's an even worse problem with this code. You probably can't see my note at the bottom because it's a little small, but there were lots of comments written here in Russian. The developer clearly copied and pasted this from another code base. That means he's committing the cardinal sin of predetermined framework selection. Rather than critically thinking and looking at the requirements of what this application needs, we're going to put the cart before the horse and try to force this application to fit a framework I've previously written, which is how we're going to get into all of the numerous failures and performance problems SDKBin's about to unleash on our customers. So my biggest failure here was essentially not asking to see evidence about decisions being made, not taking a look at the code being committed until it was way too late in the process. And we're going to get to when I did that exactly on the next slide. But another thing the SDKBin lead decided to do was he said, you know what sounds like a fantastic idea? Let's do 7 services, each with their own database. This is for a team of 2 people maintaining the system. And also, for reasons I'd never really understood, one of the other big mistake I made was not writing down architecture decision records while we were doing this. One of the very few architecture decisions that was in writing from the very beginning was we will be using SQL Azure with SQL Server. That was already written. For some reason, he built all this in Postgres. My guess, the same template he copied this stuff out of also used Postgres. That would be my conclusion there. So we get to about May of 2020, right before Memorial Day, and my developer and I were only able to overlap for maybe, I don't know, an hour and a half, 2 hours a day because of the time zone difference. And during one of our meetings where he was doing demos of the product, springs this question on me. And bear in mind, this is supposed to be a former chief technology officer, someone who has had experience running a hiring loop before. Hey, who are you hiring to build the front end of this application? I turn to him and I look and I say, well, you're the one who said you were going to build it. You remember that, right, during our onboarding conversation about this. And then I watch his pupils dilate on the call. And I realized we've got a severe problem. And this is when I started finding the problems with SDKBin. All the stuff on the previous slide got discovered about 20 minutes after this conversation happened. The long and the short of it is that I needed to take the project back in order for it to have any hope of succeeding. So our former startup CTO had described himself as full stack, but he admitted on the call he'd actually never done any front-end work. He'd always had someone else to do it. I had given him a 21 page deep balsamic mockup that was fully interactive back in January. And it never sort of occurred to him that maybe I wanted him to build that. My management failure here was not establishing agreement on what the scope and responsibilities were early and not getting that in writing. And then there was probably also some hiring decisions that I should have revised differently there too. But this is the beginning of me beginning to sort of understand how big my management failure has been at this point. So we decide that we need to go ahead and shed this microservice idea. This is insanity. It's not going to get deployed this way. We're going to condense it down to 2 services. Our user service that handles all the stuff that touches a customer when they're trying to manage their product or their billing. And then the NuGet service that deals with the fulfillment of NuGet packages. Just those 2. So the entire UI got panic built in about 8 days using Razor pages. That seemed like the fastest way to go ahead and get it to market, and that's what the developer picked. I had not been contributing any code to this project at all. A part of my management goal here was to delegate it to other members of the team and let them implement it. But now I was basically running the day-to-day sort of planning and implementation work. We pushed our launch date back from August to October. We had made public commitments on Twitter to other software developers about when this would be available. And I'm realizing at this point, dude, even if we get it out in October, there is no way I'm going to subject a company that's not us to SDK bin as a publisher. I also had to pull the Akadana engineer off of his project. He had had a lot of experience building browser-based games. He was now our front-end developer. So here's what you get when you don't have a real architecture. Now again, I apologize if this is a little small for the people in back, but this is the code behind of a Razor page. And the thing I want you to pay attention to is the number of repositories being injected into it. There's 3 obvious ones, and then there's the user manager and the authorization service, which both have repositories injected to them as well. If you see a call site like this in your application, here's what's happening. This is what's known as an application join. This means that rather than using SQL properly to get all the results back that you need to do your job, they're going to use little dinky methods in this repository to get a bunch of objects back from one object type, another objects of another object type, and then of a third and a fourth and a fifth type, and then they're going to use link to filter all this stuff out in memory. Which is why we constantly had SDK bin applications getting evicted from our Kubernetes cluster for running their memory limit over. This is on a service that has no traffic. A Google crawler could kill an instance of SDK bin because of this design. I'm not done yet. I had to cut about 30 slides of like pure code rot because of how bad it is. So I'm just showing you some of the most obvious offenders. So what I was showing you before was the code behind, which is like kind of an appropriate place to have database calls. This is the view. This is the renderer for the server-side rendering. And what do we have here? We're injecting an iFeeds repository into the view, and we're looping over all the products. By the way, this is a public-facing page on the internet you don't need to be authenticated into. And for every product, we're injecting that repository into a partial that is going to do a database query. So these are basically, like, from a flow control point of view, a little step function. And that's why this page takes about 10 seconds to load with only a handful of products in it, because inside that query is a bunch more Cartesian explosions that are happening. So we had n+1 queries anywhere, and that's generous. There's probably some n²+1 queries going on in here. And because this developer was so big on basically base class, abstract base class spam everywhere, every goddamn feature looked like this. And I didn't know about any of it until we unleashed the gates of hell on our unsuspecting customers in October of 2020. So concurrent with all this work happening on SDK bin, I was working on doing getting our new version of Phobos out, our new marketing literature, our new pricing. We had beefed up the features big time. We hit our mailing list as soon as SDK bin was ready to go. We migrated our existing customers off of their MyGet feeds and onto SDK bin, and problems started percolating up from that, performance issues primarily. But the customer said the experience of managing Phobos was a lot better. So despite all of SDK bin's problems, looked like it was going to work out okay. And then we had the thing we've been wanting all along. A customer ran their credit card through our buy path for a $4,000 a year Phobos subscription, and the system ate their payment. No receipt, no product, no nothing. We just got an alert in Slack that a new customer had bought a Phobos license, and then I took a look through our email delivery logs. Nothing. If you want a recipe for angering me, this is it. Because we are failing to deliver a product our customer is paid for. And then when I bring this up on our team call, the SDK bin lead says cheerfully, well, it's great that we can take money, as though like that wasn't the whole point of the system we were building. So it got worse. Almost nothing worked correctly. The shopping cart stored all of its prices and inventory in cookies. There was no server-side validation of the price at all. We found that, thankfully. And we had to work 3 different times to go ahead and make that system no longer bypassable. The NuGet feed system was only ever tested on a single developer's machine. We had had a dev and a QA environment this entire time. They never used it. So we found out that pushing new NuGet packages hit Cloudflare, Azure Gateway Router, and Kestrel limits on package uploads. Had to fix that. My personal favorite, because I learned how to solve this exact problem in a sophomore year computer science class, the way the SDK bin lead modeled our download trackers, so we had different dimensions: customer, package, package version, date. The way we computed the download numbers was inserting a row that had all those numbers. And the way he decided to render that display on our package listing page and in our package feed was counting all of the rows every single time we served the page. Worked great in our demos when we had about 72 hours worth of downloads, and there were like 5 of them. But when we had 50,000 downloads spread out over the course of 2 months, this added up to being like a 5-second long query. So our former startup CTO learned about database denormalization for the very first time. Our email onboarding pipeline that we wanted to have to automatically instruct people, here's how you can use your product, never got delivered. It was just too complicated to fit into our existing architecture. We had to kick that back. Cross-organization data leakage. This was a fun one. I think it was my wife who I brought aboard to help me Tiger team and QA some of this, who discovered that she could edit billing methods belonging to a different organization. That was awesome. I think you get the idea. This was, to say the least, a flaming pile of shit, but it got worse. We found this bug about 3 years later. This is Stripe.net code, and one of the things that our SDK bin lead did is we did not store canonically any sort of like payment method preference information other than the default payment method. And when it came time to do a renewal, which happened on like an annual basis, he would go through and enumerate all the payment methods that were connected to that user's account in Stripe, including ones they used with completely different vendors who were not us. So one day out of the blue, it looks like an old customer reactivates, and we run their account for $4,000. I email them and I email the customer and say, hey, did you intend to do this? Like, we haven't talked about this at all. And the customer was German, says definitively, no, we did not. I uncover this dead body behind the wall and realize that's exactly what happened, refunded the customer, but I have to eat the Stripe processing fees, which are about $350 for a transaction of that size. So I spend most of the Q2, Q3, and Q4 of 2020 essentially micromanaging my team to try to get SDK bin kicking and screaming across the finish line. So this is what I refer to as the triple burn effect. This is what my SDK bin lead was costing me. I was paying him over 6 figures a year, US. He had super high management overhead. It turns out he wasn't really a startup CTO. He was more like a junior back-end developer. That's the conclusion I drew based off of his output. And then the other thing was the opportunity costs this guy cost me. I couldn't do my normal marketing and sales rhythms that I do during Q3 and Q4, which is our best time of the year for doing sales. And on top of that, in 2020, at least, when the pandemic was going on, companies thought it might be over, so they kept their budgets open. In 2021, dude, they figured we were stuck in COVID lockdown for the long haul, and to some extent, they were right. So what did I end up having to do? I cut my own salary by 40%. I asked my Akadata engineer to limit his hours, and I also had to lay off a part-time Akadata engineer we were just beginning to train. We basically hit a cash crunch as a result of all the work we were spending on SDK bin rather than running our normal sales routines. I asked my SDK bin lead to basically share in the same sacrifice as the rest of us. And he told me it was a really bad time because him and his wife were buying an apartment building in Moscow. So against my better judgment, I let that slide. Oh, just for context also, my wife was pregnant with our first kid and had just quit her job, and I was paying full health insurance for all that. So I was under quite a bit of financial pressure. The commit it wasn't the commit, it was more like just a nice final punctuation note that finally got the SDK bin lead fired. is I had him spend most of the first quarter of 2021 trying to implement that email onboarding system using an event-driven design I had modeled with Azure Event Hubs plus its Kafka interface. And this was basically like a little outbox pattern that would take all of this awful glue code we had inside SDK bin for doing transactional emails and turn it into events that would just get rendered into live emails. I built this same type of service I'm describing here in about 2 days on TextForge, another application we launched last month. This guy spent 3 months coming up with 3 unique ways how not to deliver the solution. The greatest irony of it is, it was his own framework that trapped him. He was not able to work around how highly coupled everything was in his own design to do it. So his final commit was him deleting 6 weeks worth of work and giving up on it. I fired him the following day. Results come with consequences. I'm losing money, I've got customers that are pissed off, and I've got all sorts of distrain happening all over the business. I'll eat that for a little while, but not forever. And now we enter the despair period, the Irish famine of SDK bin. We got SDK bin limping into a stage where it mostly met our needs, but there was no way we were going to basically be able to expand it easily to support new products or to support additional publishers. The biggest one being how tightly coupled everything was to Stripe. You saw that example of the billing method management a second ago. But an issue that we discovered, and this, by the way, was not the fault of the SDK bin lead, an issue we discovered as we started working was that 70% of our customers wanted to buy via purchase orders, not via credit card. That's something that we found out after making first contact with the market. So pretty standard request, pay with purchase order, net 30, wire transfer. Our billing system is so ultra hard coded to Stripe that there was no easy way to accommodate this other than running manual SQL scripts, which is what we did. So this is basically what we ran for the better part of 5 years. SQL scripts to handle re-provisioning of every purchase order customer. And from a database modeling perspective, here's how the SDK bin lead decided to handle renewals. Rather than like inserting a row in a database to indicate a new renewal event has happened, he went and backdated when the subscription was created and added a year to it, which completely destroys auditability and is very, very brittle. So as a result of this, we lost out on 2 different market opportunities. The actual marketplace idea of SDK bin and the ability for us to add new products, like selling our support plans or being able to sell a new product we started working on in 2023. So after a couple of years of just letting SDK bin kind of do its thing, now one thing I got to give SDK bin credit for, we went from having like 3 Phobos customers to having 40 or 50. It was, by all accounts, a commercial success in terms of making SDK bin viable. The problem was, that's all it could really do. We didn't really have the ability to expand into new products and services very easily. So one thing I decided to try doing in 2023 when we're working on a new product was try to basically improve the quality of the code and the code base. So I did something as a starting point that I thought would be straightforward. Enable nullability inside the code base. All right, no problem. I do that, push a commit up to CI/CD, and watch our entire test suite go red. I think to myself, I didn't even get like anything other than a compiler warning back. How could that have happened? Well, this helps me understand why so many of our performance issues never got caught until we deployed to production. We never tested against a real SQL database ever. We were using the in-memory Entity Framework Core database this entire time. And when you enable nullability, all of those columns become optional suddenly, which completely breaks our data model. So this made me dig a little deeper into our test suite. Now, originally our SDK bin lead had built everything as microservices that worked via HTTP controllers, et cetera, and we rewrote it as Razor pages. For a guy who loved abstractions, the one thing he never abstracted was the actual business logic we used to run SDK bin. It was all baked directly into the controllers he built originally. Now, would anyone like to take a guess what he did when we added Razor pages? Baked it right into the Razor pages. And by the way, the code didn't even look similar between that and the ASP.NET controllers. This is a code coverage report from JetBrains Writer. It shows that our actual code that handled customers' money and provisioned product did not have a single test covering it. Awesome. So we made 3 valiant attempts to basically try to dig ourselves out of this hole. We began working on a new product late 2022, early 2023, and it was basically like a self-hosted Akka.NET sort of management application that we're going to distribute as a Docker container with like licensing built behind it. Well, we need to be able to get SDK to support a license server in order for that to work. Let's see what we can do to fix it. So I asked my Akka.NET engineer to spend about 4 weeks trying to solve some known performance problems on the NuGet API and looking into the possibility of adding new product types. He got back to me, and bear in mind, I wasn't asking him to write any production code. This is more of like, hey, do this assessment and tell me where the damage is. He came back and just said, it's impossible. We need to rewrite it. That should have been a red flag, but I let that go. So I had to start working on a full rewrite, and I spent about 9 months working on it, and I'm able to build a brand new version of the NuGet fulfillment service that's performant, fast, and solves a whole bunch of other problems we had. And then I take a look at the complication risk of working this back into our user service. Our user service is where all the real like dead bodies are in this code base. And I draw the conclusion that this is pretty risky and probably a lot more work than just basically essentially deferring and trying something different. I also look at maybe writing a whole separate product for doing licensing, and I scrap it. This is where we start turning things around. October 2024, a brand new Phobos customer emails us and basically says they can't use the search endpoint to find any of our products. So I decide, you know what? I'm not delegating anything this time. I'm going to get straight into the guts of the code, and I don't care how long it takes me. We're going to figure this out. So I ended up fixing the performance issue myself, from the search endpoint timing out at about 10 seconds to getting it to do all of its work in about 80 milliseconds. And it wasn't that anything was impossible, it's just that you had to swing the golf club all the way through the ball. So this was a delightful hack that I had added in 2021 when we were doing some firefighting that was still there. When a NuGet client restores packages, it looks for every package on every source. So SDK bin would get hit with these big restore storms of every package trying to get fetched at the same time. This was basically how I came up with a way, just like firefighting, to stop it from querying a bunch of packages we knew we didn't have stored in our system. This was still there in production, and I thought, you know, F me, that's my fault. So I came up with it. So after solving that by the way, I got rid of this when I fixed the performance problem. But the strategy for fixing it. Basically, rewrites always fail. The risk of reintegrating the rewrite into the main solution was too risky, couldn't do it. We had to do a strategic refactoring instead. Strangler fig pattern could work in a lot of places, but there's one place in particular it absolutely couldn't work, and we're going to get to that in a minute. This would allow us to replace pieces of the system incrementally and essentially de-risk it once it was deployed. The other thing we were going to need to do, which I guess I don't have written on here, is rebuild the test suite from scratch. So in October 2024, when I started really working on repairing the system, first thing I did, I deleted the entire test suite. Essentially hard deleted all of it. And we were going to rebuild it from scratch. The second thing we began doing is writing things down. We did not have, in the Akka.NET project, we've got a strong culture of filing GitHub issues with specifications and having open discussions, doing proofs of concept, and basically arguing back and forth. That's what you had to do for a critical piece of infrastructure like that. If I'm taking over SDK bin, that's the way we're going to do it here too. And so what we started doing is committing architecture decision records into the repository. The reason why this is so important is it creates institutional memory. Why did we decide to basically deprecate this table and start using this one? Why did we decide to introduce a cache here? Why did we decide to go ahead and delete the test suite? There were reasons for all this stuff. And then after we basically, by the way, I guess I think I stripped my slide on this, but our strategy for trying to get some emergency test coverage when we started Strangler figging, got .NET Aspire rigged into the application, got Playwright rigged into the application, and basically ran Playwright tests up and down all the different key UI flows. It is extremely ugly code we've been able to get rid of, but it gave us some test coverage that core functionality worked while we started replacing some of the guts underneath. So for our Strangler fig workflow, We basically were going to remove every Razor page. Every single piece of business logic was going to be in its own isolatable service. And the other thing we did was we started using CQRS, Command Query Responsibility Segregation. Pretty much 80% of the views on our website and on NuGet reuse a lot of the same information over and over again, but they have slightly different variations depending on what you're looking at. This cries for composition and aggregation. So we basically built read model services that would just do SQL queries. Imagine that. To go ahead and put all this information together, map it using static C# functions, no more of this automapper reflection death magic that we were doing before, and just return those out the gate. We could then test these services in isolation, we could use test containers to do it against SQL, and we could really performance profile all this stuff. So when we fixed one area, we fixed it all the way down the stack. My goal was get rid of that generic repository bullshit. That's the first thing, that's what I really wanted to get rid of. So replace the Razor page with an equivalent MVC controller, validate that all the routes worked, extract view context service that basically populated our views, and a command processor for doing the writes, treat read models and write models independently of each other, and then add tests to it as we go. So it says here 90 pages we started with and we're down to 46. I think it's a lot lower than that now. I think we're down to maybe 28 Razor pages left, but we've gotten rid of most of them. Now here's the key detail about AI, which kind of entered the picture in 2025. I originally tried having AI do some work on SDKbin before I had a chance to really rip the guts out of it and start rearranging it. What do you think an LLM does when it sees 400 uses of the repository pattern? More uses, that's right. The LLM gets pulled really hard in the direction of the existing code. So what I had to go in was essentially quarantine the LLM from poisoning itself by looking at our old bad code we wanted to get rid of. So I would go ahead and establish a pattern of something that was successful, tell the LLM read this first in planning mode, get a clean context and say, okay, here's the cancer I need you to remove from this other adjacent area of the code. And that process of basically not tainting the LLM worked pretty well. So this idea that it was impossible to go and refactor the system was really more of a matter of courage rather than genius. Do we have the guts to take on this risk and essentially replace the foundations of this application without letting all the floors fall on top of it? So here's an example of some things we did. The authorization system that we had originally was essentially untestable the way it was designed. You had these attributes that described authorization policy, and there was nothing really wrong with that. But look at all the little sprinkled granular access check code inside the HTTP handlers on this Razor page. That's not really testable without something like a playwright test, where you're actually getting the user to log in, et cetera, et cetera. What we migrated to on the right was a stackable authorization policy on an MVC controller, where you have a signed-in user's role, a customer, then you have an object they're acting against, their organization, and then a verb, write billing. We could go ahead and write an XUnit theory to exhaustively test all those different combinations and validate them against different users and figure out can this user perform this action? Are they excluded from that one? We have something like 160 tests now that guarantee tenant isolation and also guarantee nothing like a user with this credential can't do this thing they're not authorized to do. Completely covered with tests now. So the AI really helped amplify what we were doing, but like I said earlier, we had to make sure we were doing the right things first. One of the things that's really important is you can't take AI and point it at a blazing inferno of technical debt like this and say, fix it. You have to lead by example, even with an artificial intelligence. So coming up with things like the stackable authorization, migrating back to controllers, extracting the view context and getting rid of the automapper stuff, all those healthy patterns, we had to kind of set an example manually first, and then very gingerly have the LLM help us start carving out the rot from the other areas. So you can see here our velocity really picks up starting in Q4 of 2024. Our configuration system for SDKbin was hundreds of environment variables spread out in dozens of files. Microsoft.extensions.configuration existed at the time this application was built, I have no clue why the original developer chose not to use it. So the first thing we had to do was get all the configuration in one place so we could actually understand what changes behavior inside the system. So we spent a good chunk of Q4 doing that and fixing lots of performance issues with SQL until basically we were able to get all of these SQL timeouts reduced to 0. And then we started working on a lot of the finer touches. This is probably too small to see up here, but this piece of code is an email link generator. One of the biggest pain in the ass areas that impacted customers a lot when we were refactoring is all of the links breaking on the transactional emails we sent whenever we did anything on the site. So we came up with basically a statically typed way of generating email links reliably and injected all of this into some verify tests. We basically did snapshot testing on all of our transactional emails. That way, if I refactored a Razor page to an MVC controller, I could see the route go missing from the email and catch it like that. So we used our test coverage to basically help guarantee that a lot of these refactorings we're making were safe by adding these sort of horizontal testing infrastructure components for validating the links we generated on emails, validating that all of our routes resolved correctly, validating our authorization policy, all that stuff. And now the biggest monster of them all, our billing system. The old system basically had one actor running on each instance of the server, running on a timer, trying to basically poll for when we needed to bill a customer. And that's how we ended up with all this wacky stuff where like customers could get free product if we ended up missing a billing window. There's no coordination at all. And we also did things like coupled a Stripe payment intent and turn that into an invoice. We treated those two objects like the same thing. They're related, but serve very, very different purposes. That's a good example of bad coupling right there. Another requirement, again, this is like a requirement we didn't know about. We keep the like pay by date and the service disconnect state as the same thing inside our system. Quick show of hands, who's ever had to work with a procurement department before? All right, these people are not winning Mensa awards anytime soon. Things run late. People take weeks to send a single email that has like a vendor survey we have to fill out on it. That's sort of what your big corporation procurement department looks like. A grace period is basically your way of communicating to your customers or engineers, we know you're trying to pay and we're not going to disconnect your service because I know you're working on it. This system did not have that concept built into it, and that's a requirement we kind of discovered later. But it's kind of ironic that a company that makes distributed computing frameworks didn't actually use it at all in their billing system where it would have been a really good fit. And that's one of the issues that we're fixing here. This is like a chunk of my actor, my subscription actor that has 11 different states. It describes all the different parts of all the different billing life cycles. And the most important thing it captures are the failure modes. What happens if someone tries running their credit card, but it fails? Today, SDKBin sends an email to the user and waits for them to log in and supply a new payment method. We have probably lost tens of thousands of dollars with a business that way. The correct industry standard way to handle that is through what's called a dunning process, where you retry billing like n number of times before you give up on it, and the user has to intervene. The subscription system now handles it. And this is what I talked about where Strangler Fig doesn't always work. In order to do the billing system replacement, to handle the new requirements like grace periods, to handle additional billing providers like purchase orders, and rewriting the Stripe system so it actually kind of functions reliably, I am up to about 76,000 lines of code on one pull request. I have to replace the entire system all at once because the Stripe APIs are so deeply ingrained in all of it. So where are we now? We have .NET Aspire for integration testing, Playwright for end-to-end sort of like testing of the application, and we have, let's say, probably about 60% test coverage over our entire application. Our authorization system works great. AutoMapper is still there. I have a note in our company Slack that when we finally delete the AutoMapper NuGet package, I am buying an espresso machine for the office. We have 17 ADRs in the billing system alone and others in different areas of the application for things like describing the dynamic authorization policy. And we're not done. SDK bin is going to be the best turnaround story of my career, and it's long been a gigantic source of embarrassment for me. So here's what I learned about things I need to do differently in the future from here. Have the 15-minute conversation. Just because you have a team member you trust doesn't mean they're on the same wavelength as you, and doesn't mean they understood. Basically, your understanding with them might not be shared. You need to get to the bottom of that early and often. My manager at Microsoft put it really well when I worked there. You have to reestablish agreement with the people you work with every day. So that's really what the first bullet point's about. Make sure you all agree we're working towards the same thing the same way. Second, write it down. Got to write it down. Architecture decision records are institutional memory, and you need to preserve it. The third thing, if you're a manager, you got to turn over rocks sometimes. When you hear something suspicious, like the word impossible being used to describe a pure software problem, if that person hasn't furnished you with a proof by exhaustion, it's not impossible. It's more like, I don't want to do it, or I don't know how to do it, or I'm not sure if we should do it. Therefore, you really need to pull on that thread and see what's going on there. Number 5, sometimes you have to work on just one thing, even if you have a lot of competing priorities. That's the only way to make forward progress, is doing deep work on a big project. And that's been the hardest lesson for me to implement. And then sometimes you just got to do it yourself. So if you're sitting there with your own version of this, a code base you're embarrassed by, or a system you know is broken, go ahead and just start with that today. My sort of attitude on this stuff, and I think I mentioned it earlier in the talk, is that courage is in shorter supply than genius. Fixing SDK bin's problem wasn't a matter of not knowing how. It was a matter of committing to actually doing it. And when we finally did it, we've made great progress. Any questions? How am I still around after all that? I think I gave this advice to another speaker at another conference years ago. Anger sustains. It's like that sort of expression, being too angry to die, you know? No, in all seriousness, I would say a lot of it is, I've seen the results of what we've gotten with a system that's this crappy. What could it do if it was great? And that sort of spark of promise has kept me going. Like I said, for all intents and purposes, despite SDK bin's problems, it's not been a commercial failure for us, for Phobos. But there's so much more it could do, and that's what keeps me going. All right, well, if you guys have any more questions for me, I'll be packing up here and I'll be waiting outside. But thank you very much. I really appreciate it.